In this problem we are to solve for x for the following exponential equation. Because the input variable x is in the exponent position, we call this equation an exponential equation. To solve an exponential equation in this class, you could follow the four-step process, where step 1 is to isolate the exponential term. The exponential term is the base and the exponent that contains the input variable. That would be this. Isolate just simply means to get it by itself. So we need to get the 16 to the other side. Since the 16 is being multiplied, we will divide both sides by 16. Over here, 16 divided by 16 is 1, so we're left with 1 times e to the x, which is e to the x, equals 3/16. This is where you're probably tempted to reach for your calculator and figure out what 3/16 is as a decimal. In this problem, though, I want to get an exact answer before I get an approximate answer. So I'm not going to be using a calculator to get a rounded approximation here. Now that I've isolated the exponential term, I'm on to step 2. Step 2 is to simply take the natural log of both sides. This literally means that you can take the ln and plug in the left-hand side of the equation into there, copy the equal signs, and since I took the ln of the left-hand side, I have to take the ln of the right-hand side as well. So I will be copying the 3/16 in this set of parentheses. So copying the left-hand side in here, the right-hand side in here, I'm done with step 2. I've taken the natural log of both sides. Step 3, sometimes I do step 3 differently depending on whether the base is e or not. The first part of step 3 says if the base is e. In my problem, the exponential is a base e. So it says use the property that the ln of e to any exponent would simplify down to just be that exponent, and whatever is in the exponent would no longer be in the exponent position anymore. So for example, since my problem has the ln of e to the x, where you see the word stuff here, I have just the letter x. So it turns out that since we're plugging in a base e exponential into a base e logarithm, and because exponentials and logarithms are inverses of each other, these cancel each other out and I'll just be left with x. Because my stuff is x, this simplifies out to just be x. In other words, it's almost as if you can consider these things canceling, but then realize that the x is no longer in the exponent. So when I write it, this will just look like x equals, and I'm done solving for x. So x turns out to be the natural log of 3/16. This is what we call an exact answer. The reason an exact answer is powerful is if I leave my answer like this, I can always get as many decimal place accuracy as I want by typing it into a computer and telling the computer how many digits I want. In today's technology, it'd be very easy for me to get several thousand decimal places if I type this in. However, once you type this into a calculator and get a decimal approximation, whatever you round that decimal to would be the most accuracy that you'd ever get. If you want an approximation of this, simply type this in as it appears here and round to how many decimal places you'd like. By the way, there is a step 4 to this process that says solve the equation for the input variable. The reason I skipped step 4 is we were done after step 3. Because my exponent only had the letter x here, there was nothing to solve at the end.